Okay, 3.8 reference angle. What are reference angles? Okay, let's read the definition here. Let theta be an angle in standard position. What is the standard position? Yeah, by the time we should be able to see what standard position. We start from the 0 position on the quadrant, and then it will count, it will measure the given angle the counterclockwise, right? So that way we verify the given angle is standard position. And if that was defined as the original angle, then we should be able to find the reference angle of the original angle. So its reference angle is the acute angle. So sometimes it notates theta dash or theta apostrophe like that, but it's more like a traditional way that we call it alpha. So the original angle theta and its reference angle is alpha. I'm more used to the way that we call it alpha, okay? So sometimes I will call it alpha. So then you just notice that's what I'm talking about as alpha is the reference angle of the given original angle. That's it, okay? But it says it's acute. What's acute? It's any angle less than 90, right? Within 0 to 90. So its reference angle is always acute. It's less than 90. Then how do we find it? It's the angle that is defined by the terminal side of the original angle theta and the horizontal axis that is nearby. Horizontal axis. What are you talking about horizontal axis? Look, now we are using any angle placed on the quadrant space, the coordinate space. Here, we always start from x-axis and y-axis. Between x-axis and y-axis, which one is horizontal? Yes, x-axis is the horizontal axis. Then, what it's saying here is this. If my original angle theta is already acute angle here, so that means we see the original angle theta is placed within the quadrant 1. Then, now where is the terminal side of the original angle theta? Here. Then, with this terminal side indicated, then there's gonna be another angle that forms with the original terminal side and nearest horizontal axis. So with this, not this one, this is a vertical axis, but this is the horizontal axis nearby of the terminal side of the original angle theta. So then now this is the reference angle of the given original angle theta. So in quadrant 1 happens to be same. Original angle theta is the same as reference angle alpha, or if you want to look, call it theta apostrophe, and then it's just the same. So then in quadrant 1, they happen to be the same, but it has to be acute. Yeah, it is acute. The original angle is also acute, and then it all makes sense. But what if the given angle is not in quadrant 1, right here, quadrant 2, quadrant 3, quadrant 4, then it's a different story. Then that's what we're going to explore today, okay? So once again, what you have to remember is whatever the angle placed at, either quadrant 1, 2, 3, 4, anywhere in this coordinate plane, properly you have to figure out what could be the reference angle of the given original angle. But each quadrant, except the quadrant 1, it's going to give you different perspectives there, okay? So that's all. But all you need to know is the reference angle is always acute, even though the original angle is not acute, the obtuse. Then the way that you find it is wherever the terminal side of the original angle placed, and then with the terminal side in, not y-axis, but nearest x-axis will define that reference angle. That's all, okay? So then erase this and then let's move on. So now we have this, the quadrant with the circle, its center is placed at the origin. And from positive side of x-axis, we start from there. So now I see 0. Then standard position, we count any angle from the 0 position and counterclockwise, and then it's gonna go 90 pi over 2, 180 pi, 3 pi over 2, 270, and then 90 more, and then we make 2 pi in the same position. Goes all around there, right? Here. Then, as I said before, let's say I have a given original angle in quadrant 1. So let's say my terminal side is here. Then original angle theta has a terminal side is right here. Then now I'm supposed to find the alpha, the reference angle. Then where is terminal side of the original angle? Right here. Then where can I find the nearest horizontal axis? It's right here. Not this part, but this part. This is nearest horizontal axis, not this part. It's nearest, but it's vertical, so I don't count that. Only this one makes that angle. So where is the angle measured? Right here. From this to that, and then this could be alpha or theta apostrophe there, right? So then this is the reference angle. So in quadrant 1, I can definitely see the original angle theta is exactly same angle measure alpha, so reference angle is the same angle with the original. Okay, so that's done. Then what if I have angle whose terminal side is placed at quadrant 2? Okay, where is the quadrant 2? It's right here. Quadrant 2 is right here. Then what kind of angle do I get? And let's start with measuring 5 pi over 6. I know for sure the terminal side of the angle 5 pi over 6 is in quadrant 2. How do I know? Now, pi over 6 means we divide from 0 to pi into exact same 6 pieces. 1, 2, 3, 1, 2, 3, 4, 5, and then now I have that, right? Okay, so let's erase this. It's too much. So now I know my terminal side of the angle. And if I go through 5 of pi over 6 pieces, then where is my terminal side? It's right there. This is my terminal side right there, right? Okay, then I recognize the position of my terminal side of the original angle theta here. Then the way that we verify the reference angle is with the terminal side. Now I have to look for the near horizontal axis. Where is it? It's right here. This is the nearest horizontal axis. So then now the mint color highlighted piece should be the reference angle alpha. Then what is the measure? The pi over 6. How do I know? Because we use this logic. All the way here was 180. But if I take this yellow highlighted, which is the measure of the original one, take away, then I consequently get the piece that indicates, represents the reference angle. So algebraically, what do I do? First, I write pi, all the way pi. I take away what? The original angle value of 5 pi over 6. In order to calculate it in radian, what do? I consider this one as pi over 1. And I have to set the denominator the same. So I multiply pi over 1 top and bottom by what? 6. And then it's going to make 6 pi over 6. And then I take away what? The original angle measure, 5 pi over 6 right here. Then the calculation should give me pi over 6. Then it is the angle measure for the reference angle on this. So we can utilize any angle its terminal side is placed at second quadrant with this formula, right? So let's erase everything. So then for quadrant 2, we will do 180 minus or pi minus the original angle is the formula to figure out the reference angle alpha here. Okay, then compared to this, let's see what happens for quadrant 3 and quadrant 4. Okay. Then if your given angle is on the quadrant 3, this is quadrant 3 here, then which angle should we use as an example? Let's say pi over 4. How do we know pi over 4 here? Look, pi over 4 is nothing but even same pieces that we divide pi into 4 even 4 pieces. So it's going to be like this. 1, 2, 3, 4, and then 5 pi over 4 and one more. 5 pi over one more. So now my terminal side is at definitely on quadrant 3. So original angle theta 5 pi over 4 is there. Then now I have to verify the nearest horizontal axis. So not this one, not this horizontal, it's further. So then now I have to make an angle with this nearest horizontal axis and the terminal side of the original. And then now this must be the alpha, which is the reference angle of what? 5 pi over 4. So then now I have to figure out the mint color highlighted piece. How do I do it? Then I see the structure here. I measure all the way down here, but as long as I take this upper hemisphere there, then I will get this mint color highlighted part. So the calculation goes like this. I copy the original angle measure first, and then I take away what? The pi piece, the half of the circle piece. So I'm just taking away. Then in order to match the fractional calculation, pi over 1, and I multiply top and bottom by the denominator 4 and 4. Then I calculate it here, then I get pi over 4. So this mint colored piece as your reference angle measure is pi over 4. Okay, then what was the formula for the quadrant 3 reference angle? The original angle theta, I subtract what? Pi or 180. Okay, so far so good. Unless you guys have any mind-boggling question, and then I will move on to the case in quadrant 4. Okay. Then now what's happening? In order to have my terminal side placed at quadrant 4, I will use the original angle goes by 5 pi over 3. How do I notice my 5 pi over 3? So then look, we are dividing pi into 1, 2, 3 even pieces. Then here I have one more, so it's 4. Then I have one more, and then that's 5. So that's how we got all the way down here the original angle. Erase everything. So now we can notate the original angle all the way here. Let's measure theta 5 pieces of pi over 3. Okay, then I notice my terminal side is definitely at quadrant 4 here, right? Then now I have to define the reference angle with this terminal side that I obviously can see. Where is my nearest horizontal axis? It's right there. Not this one, not that one. I go with this. Then this mint highlighted portion is definitely the reference angle of the original angle of 5 pi over 3, right? Then what can I do to formalize this situation? Here, notice that we can measure all the way 360 or 2 pi. But as long as I take this original angle measure highlighted in yellow, take that out, then I can be with the leftover, the mint color there. So the formula where its terminal side is in quadrant 4 is you write 2 pi 360 first, and then you take away the original angle theta. Then this is over 1, and set the denominator the same, 3. So multiply top and bottom by 3, so it's 6 pi over 3. And then take away the original angle theta there. Then you should get the measure of this. So it's pi over 3. So then in quadrant 4, the formula is this, 2 pi or 360. Take away the original angle measure and you will get the measure, right? Okay. Then, once again, let's summarize everything. Quadrant 1, original angle theta is exactly the same measure of the reference angle alpha. In quadrant 2, so this is theta and then this is alpha. Then in order to calculate it, it's 180 minus the original angle will give you the reference angle alpha. Then in quadrant 3, so if this is the angle, then original angle all the way here is theta. Then the alpha is only this. This is the alpha. Then quadrant 3, the formalization for the alpha is you put original angle first, and then you take away what? The 180, it's upper half circle. Then you're gonna end up having the measure of the reference angle in quadrant 3 in this way. Then if you have any terminal side placed at quadrant 4, so all the way here, but it can be calculated, this reference angle alpha in that piece is 2 pi all the way 360. You take away the original angle theta, then it gives you the alpha in quadrant 4. Then over all of this, then what you have to remember is quadrant 1, alpha is here. In quadrant 2, alpha is here. In quadrant 3, alpha is this one. In quadrant 4 is alpha is this one. So then if you connect those dots and it gives you guys the big bow around the each axis, then if you remember this bow, big bow around the quadrant, and then it's going to give you some instant logic there. So either way, you can go by each quadrant, how you get reference angle of its original angle, as I just showed you. And if you just want to remember right away, and then just remember this bow right here. So quadrant 1 is the same. Quadrant 2 is this much. Quadrant 3 is the other. It's a mirror image. And then quadrant 4 is a mirror image of the 1. So 1, 2, 3, 4 goes by this. So either way. Okay. Before we see actual examples, any questions so far? That's good. Okay. Then this slide shows, except the quadrant 1. Quadrant 1 is just as itself. So theta is alpha. Then this is the formula for quadrant 2. This is formula for quadrant 3. This is formula quadrant 4. Then now this is the piece. This is the piece. This is the piece. Okay, so you can remember this diagrams for each quadrant, and then you can just go from there too. Okay, so I gave you various ways to remember this. Okay, then let's take a look at the actual examples. So if it says the original angle that you're given with is 300, first you have to see which quadrant that original angle 300 degree is placed at. So then let's draw our diagram really quickly. So since the original angle measure was given in degree, I can go by the degree. So here 0, 90, 180, 270. So it must pass the 270 and 30 degree more. And then now I know for sure my terminal side is at quadrant 4. Then what is the measure? From the position 0 all the way up to the terminal side, which is the theta measure, is 300. Then as we know from previous approach, the alpha is this measure right here. Then how do I calculate it? I put 2 pi 360 up front. And then what I have to subtract is the given angle theta measured 300. What is the difference? You take away 300 from 360. Yeah, it's easy. It's 60. Then what is this 60? 60 is the reference angle there. So right here, I have better diagram here. So all the way 300, and then it was taken away from 360, and then this alpha is 60 degree. So the answer is 60 degree. Okay, that was easy. Then let's take a look at the second one. So the second example is this. It's kind of weird, but I think you guys already saw this type of measurement here. So this is radian. It's not degrees. There's no degree measure. It's radian, right? So then let's guess which quadrant is 2.3 radian. Here, I will give you the key. I always make a standard point with a pi, right? So pi is equivalent to the degree measure 180. But we also know the actual value of pi. What is it? It's approximate is 3.14. Then my logic goes like this. Here, this is 0. Where was pi actually? We notate this side as a pi, right? Then pi is same as what? 3.14. Then if I go further and then if I just go back here, how much is it? It's a 2 pi. Then if I rewrite as 3.14, it's twice of 3.14. It's just around what? 6.28 there. So then this is about 3.14 here. And then this is about 6.28, right? Then in order to measure the placement for 2.3, we know for sure it's not gonna be quadrant 1. It should be between this and this, so it's quadrant 2 there. Okay, then let's see better approach for this. So now, if we know the given angle theta being 2.3 is quadrant 2 right here, then I can follow this formula and I will write pi up front there, and then I subtract what? The original angle theta up to that point, 2.3, right? Okay, then the calculation is 0.8416. But what is this? That's the reference angle here. So this measure is for the reference angle. The piece is here. This is reference angle, right? Then your answer should be 0.8416, and probably it will say what decimal point for you guys to just round up or something like that, if that was the actual test problem, right? So then that way we can figure the reference angle measure. Does this make sense? Are you all good? Okay, then one more example here. Okay, then the last one was given original angle theta is -135. Here, we need to be really careful. It was measured in a negative way. In order to measure an angle on quadrant in a negative way, from the starting, the initial side, I will not go this way. I have to go down way, right? So let's see the diagram here. Once I measure -135, I start here and then I have to clockwise 135. So I go -90 and I have to go -45 more. So I know for sure my terminal side is at quadrant 3. Then in order to calculate the reference angle, based on the definition, we are using the standard position again. So then instead of using -135, I'm using +225 from initial side, counterclockwise 90, 180, up to the point I have to go 45 further. So then the theta becomes +225. Then since we are calculating reference angle in quadrant 3, it's original angle 225 positive now, and then I have to take away 180. That's the formula for any angle placed at quadrant 3, right? So then I can see the measure of the reference angle 45. 225 minus 180. That's why, right? Okay, then that way I know the reference angle is 45 here. Okay, so by covering all 3 types of examples, you should be able to do practice problem in 3.8 fine. And by knowing this knowledge, it's gonna help you guys to figure out all the problems that are assigned in the depth of knowledge assignment as well. So feel free to just try it. And I want just close until December 5th. So you have decent time to utilize all 3 attempts there. And so that was all for today, right? Okay, so